Okay, our today's topic of discussion is how carbon dioxide is transported from tissue to lungs. So to understand that, let's assume these are some tissue cells and this is a blood vessel you can see. Now carbon dioxide will come out from tissue and 7% of carbon dioxide 7% of carbon dioxide will transported by plasma and the left 93% will transported by RBC. Now let's take a closer look to the RBC so that we can write down all the mechanism related to it. Okay, let's know some facts at first about the RBC. So the membrane of RBC is known as Donan's membrane and it has a cool property, that is it's only permeable to negative charge. Okay, now 70% of CO2 will go into the RBC and this CO2 will combine with H2O in it in the presence of carbonic anhydrase enzyme. Okay, remember the enzyme name, carbonic anhydrase enzyme. Now these two will make H2CO3, which is our carbonic acid. Now this carbonic acid will dissociate again in presence of carbonic anhydrase enzyme into H plus ion and bicarbonate ion HCO3 minus. Now remember the property that Donan's membrane is permeable to only negative charge ions. So this HCO3 minus, which is a negative charge, will come out of RBC into the blood, right? This HCO3 minus bicarbonate ion will then react with Na plus ion, sodium ion present in blood, and will form NaHCO3, which is sodium bicarbonate. Then in our RBC there is KHBO2, which is potassium oxyhemoglobin. Okay, this potassium oxyhemoglobin will again dissociate into KHB and O2. This O2 will go back into the tissue cells. Now that is a important source of oxygen to the tissue. This KHB will again dissociate into K plus and HB. This HB and this hydrogen will react with each other, HB plus H plus, which will form H dot HB, known as hemoglobin acid. Hemoglobin acid. Here is 7%, here is 70%, the left 23% carbon dioxide will now come into the RBC, which is 23% of carbon dioxide, and this will react with HHB, which is our hemoglobin acid, and it will react with the amine group of HHB and will form H dot HB dot NHCOOH, which is known as carbaminohemoglobin. Let me carbaminohemoglobin. Okay, 100% of carbon dioxide is already dissolved into the blood. NaCl into our blood, which will dissociate into Na plus and Cl minus. This Na plus will go to bicarbonate ion to react, and negative ion is permeable to Donan's membrane, that is Cl minus will enters into the RBC and will react with the leftover potassium ion K plus plus Cl minus, which will form KCl. So the 100% of carbon dioxide is dissolved into the blood, and that is the complete mechanism of carbon dioxide transportation. Thank you.